All right, this is section 6.3, systems of linear equations in three variables. All right, so let's zoom in here a little bit. So just some notes first. So to solve for two unknowns, which we've already done, you need a system of two equations. We saw that in section 6.1. To solve for three unknowns, you need a system of three equations, and we're going to start seeing that this section. All right, some other notes: solutions are points of intersection. XY is a point in two-dimensional space. XYZ is a point in three-dimensional space. And the solution to the system satisfies all equations of the system. And that was true also with a two-dimensional or a system of two equations. All right, so let's look at this example. Determine if the order triple is a solution to each system, and we'll check if A, B, and or C are solutions to each one. Okay. To find out, we just plug in the numbers. So I'm going to label them A, and I'm going to plug in just the numbers. So it's x plus y minus 2z equals 3. Negative x minus y plus 3z equals negative 1. Notice I'm just writing the equations. X plus 2y plus z equals 12. And then put the numbers in there. For A, it's 2, negative 2, negative 4. 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 All right, and satisfy means that when we plug in the numbers that it's a true statement. Of course, we may have to simplify a little bit, right? Like here, this is 2 plus negative 2 is 0, plus 8 is 3. Okay, so that one we already know doesn't work because it does not satisfy the first equation. So A is no, right? By the way, it's a yes or no question. Is it a solution? Okay, let's try B. The triple 0, 4, 6. Okay, same equation, right? X plus y, I'm sorry, same system, equals 3, negative x minus y plus 3z equals negative 1, and x plus 2y plus z equals 12. And again, we're just going to write in the values we're given. So 0, 4, and 6. 0, 4, and 6. And these are in order, so the numbers are just in order. All right. So is 4 minus 8 minus 12 equals 3? No. So that's not a solution. So 0, 4, 6 is not a solution to the system. 2, negative 4 is not a solution to the system. Let's try C. I'll write C up here. And again, the equations are x plus y minus 2z equals 3. Negative x minus y plus 3z equals negative 1. And x plus 2y plus z equals 12. All right, fill in my values for x, y, and z for letter C, right? So it's 4, 2, and 3. 4, 2, and 3. 4, 3. 4, 2, and 3. All right. 4 plus 2 is 6, minus 6 is 0. Okay, so that one doesn't work already, so the answer is no. So none of those, A, B, nor C, none of those points is a solution to the system. Okay, if we had found one of them that was a solution, but not the others, and so for this one we take the no, and the no, and that says no, right? So if there's just a single no, the answer is no. In order for the answer to be yes, all three have to give you a yes. I'm sorry, no. In order for sorry about that, I got a little confused. So each of these is a yes or a no, right? In order for it to be a no, at least one of them has to give you a false return, right? Like here, we on the first one we got already that it's not a solution. Here on the first one we already got that it's not a solution, and here on the first one we already got that it's not a solution. In order for it to be a solution, all three equations have to turn out true, right? That means the left-hand side has to equal the right-hand side. And here, just the first equation was not true, so the answer is no, right? It doesn't matter that it's a solution to any of the other equations. Yeah, we already got that it doesn't work on the first one, so the answer is no. Okay, all right. Let me see if there's any. All right, and so we'll do the same thing with numbers 2 and number 3. but we'll do those in class. All right, let's look at one more thing, and that is we're going to set up equations. We're not going to solve them yet. We're just going to set them up. Let's try the first, let's try number 5, and we'll do number 4 and number 6 in class. All right, so number 5, Jesse invested $10,000 in 3 investments, some earning 6% annual interest, some 7.5%, and some 8%. The amount invested at 5% is $2,000 more than that invested at 8%. The total interest at the end of the first year is $640. All right, so the instructions tell us to write the system of equations, but to give the definitions of the variables. Okay, so I'm going to say my variables are going to be X, Y, and Z. Okay, and you can call them any value, any variable names, A, B, and C, whatever suits your fancy. Okay, so I'm going to say X is the amount invested at 6%. Okay, or I can say, yeah, let's amount invested at 6%. All right, Y will be the amount invested at 7.5%, and Z will be the amount invested at 8%. Okay, so we're going to write 3 equations. So the first one, the first statement tells us that there's 10,000 invested, so X plus Y plus Z will be 10,000. So I'm going to write that. X plus Y plus Z will be $10,000. That's my first equation. All right. The second statement tells me the amount invested at 5%. Oops, I think it's 6%. 6%. All right, so the second statement says the amount invested at 6% is $2,000 more than that invested at 8%. So X is 2,000 more than Z. Yeah, X is 2,000 more than Z. So if we take X minus Z, that'll give us 2,000. So I'm going to write it this way: X minus Z would be 2,000. And then we need 3 equations. Remember, the total interest at the end of the first year was $640. Well, the interest came from 6% of X, which we can write as 0.06X, plus 7.5% of Y, 0.075Y, plus 8% of Z, so 0.08Z equals $640. That would be the system that we would want to use to solve the problem. Okay, well, we're going to leave it at that, and we'll do setup 4 and 6 in class. Okay, so that'll be the end of section 6.3. And we will solve some in section 6.4. Okay, but not yet.